Welcome back, my dear friends and dear students. A very good morning, good afternoon, good evening to all of you, wherever you are in part of this world. And this is the DADM 2 lecture under the NPTEL MOOC series, and as you know, this total course duration hours wise is 30, which is for 12 weeks, and the total number of lectures is 60 because each lecture is for half an hour. And as you can see, this DADM 2, which is data analysis and decision making 2, we are in the 6th week, which is the 28th lecture, and that means we have completed 2 lectures in this 6th week, and we are going to the 3rd lecture for this week. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur in India. So, if you remember, in the last class we were just doing brief study of how electro process could be utilized without going to the logic of how the derivations were done. And if you remember, you are discussing that trying to collect the information of the concordance index and put them in the concordance set or in the concordance matrix based on the fact when you compare each and every alternative with the others based on each and every criteria. So, we have already done that. Also remember one important fact, that the normalization initially which you had done was along the rows or the columns, the whole steps would be exactly the same, and you will do the normalization based on the fact of the utility function. These points I keep repeating, so but please bear with me. And the concordance fact and the discordant facts which you have done was based on the relative distance. Also that means on the blue line and the red line, on the right hand side liking, hence in concordance set, in the left it should be in the discordance set, but we will have a different formula for that. Also remember, the final C matrix is an asymmetric one, but the important fact is that the of the diagonal elements when you add them up is basically 1. Now, continuing the step 4, we have already completed finding out the C matrix, and now we will try to find out the D matrix based on the discordant indices or index values. The discordant matrix D expresses the degree that a certain alternative AK is worse than in the competing alternative, whatever the competing alternative is. It can be AL based on the criteria as j is equal to 1 to n. So, I will compare A1 with A1 based on all the criteria, then I will compare A1 with respect to A2 with for all the criteria, then I compare A3, A4, A5 individually till AM with respect to A1 based on each of these criteria taken as groups. So, the elements of the discordant matrix, elements means small d 1 1, small d 1 2, so on and so forth along the first row, similarly for the second row, third row and so on and so forth, would be given by the maximum values of levels which you have. So, what I will do is that I will basically have a set. So, DKL, now remember you are trying to basically compare the K and the Lth one based on K, L and Lth one the alternative based on the criteria, and this j value will change from 1 to n. So, you will basically find out the maximum distance or the maximum value for all the sets which you are comparing, and then divide by the maximum so called combined of the whole so called population which you have. I am using the word population in a very general sense. So, these ratios would definitely give you the values of the discordant set or my matrix elements. Now, again I will request, if you remember, if you have your notes when you are studying it, you have that Y matrix, all those values were there, the 1 comma 1, 1 comma 2, 1 comma 3, similarly 2 comma 1, 2 comma 2, 2 comma 3, 3 comma 1, 3 comma 2, 3 comma 3, those values were there. You will keep repeating that, utilizing that for finding out the C matrix and the D matrix. So, the values of the D's are to be found out. So, D1 1 2 would be given when you are comparing the first and the second values, and you will basically keep repeating it and try to find out the maximum score in the numerator and the denominator. The value will come out as 1, that means the maximum ratios is 1. Similarly, for D13 is 1, D13 is 1. So, I am again repeating, please have that set y and based on that you do the calculation. So, if you remember D12, D13 are the comparison which you are doing along the rows and the columns at each step. D21 is 0.31, D23 is 0.64. Just pause, have a look at these values. When I continue, I have D31 and D32. So, again in the similar way, the values of C's which I have considered, the principal diagonal values were of no consequence. So, they were dash dash dash. In the similar way, when I do it for D, so I had done it for D32, D32 and D12 and D13, then I had done for D21 and D23, similarly I have done for D31 and D32. The values are given. So, thus the discordant matrix D is also an asymmetric one along the principal diagonals and the values are given. Now, remember here the values need not add up to 1. So, if you have seen that. So, it means when I am comparing the first with the second in the level of disliking, I am getting a score of 1, but if I am comparing 2 with respect to 1, that means in the first case 1 with respect to 2, this means I am taking 1, hence my level of so called dissatisfaction is 1. When I am comparing 2 to 1 and I am taking the decision 2, my level of dissatisfaction is 0.31, which technically means if I am trying to compare the level of dissatisfaction, I am less dissatisfied by taking 2 than with respect to 1. In the similar way, when I am taking the level of satisfaction, it was also taking one decision at a time, trying to take the positive sense and then trying to compare. So, the discordant matrix D is given by the values. I will only read the values which is here. Dash is basically the first 1 comma 1 would obviously be dash 1 1, 0.31 dash 0.64 dash being for 2 comma 2, and the third row is 0.371 and dash, that dash being for 3 comma 3 cell. Now, in the next step, fifth, you have already found out the concordance indices based on that capital C, then already found out the discordant indices based on that capital D. Now, you want to compare them. Remember that there is a threshold or concordance index which is dependent on decision maker's choice, how good or bad or how strong the liking is. So, alternative AK will dominate AL if and only if that value of AKL, that means when I am comparing these values of C in that capital C matrix are greater than some C star value which I have. That means, if they cross that the threshold, I am positive, I will take that decision. Now, C star is calculated in a similar way as we do in the case of, say for example, statistics, we have the value of sigma hat square. Hat is basically the estimated value. When you take the hat value, you remember that you will try to find out the best estimate for the standard deviation for the population using the standard error from the sample, provided the sample mean is not known. Hence, you will replace mu by x bar n. I am talking about the normal distribution only, and the overall formula, if you remember, it will be the summation of the squares. So, what are the square values? It will be xi minus x bar n whole square for each and every term as I changes from 1 to n, and in the denominator you have divided by n minus 1, because that minus 1 is coming because you have lost 1 degree of freedom based on the fact that you have utilized the sample set from x1 to xn to at least one time to find out the best estimate for the population mean, which is the sample mean. Similarly, you will lose 2 degrees of freedom, 3 degrees of freedom depending on the problem. So, this is something of that sort. You will basically multiply by m into m minus 1 and add up all the values of C, K, L values of which are there, comparing the A kth and the A Lth one based on each and every criteria. So, that is C star. Greater than C star, I assign the values, less than C star, I do not assign the values. So, C star value comes out to be 0.5 of half. Based on that, I will basically have the concordance dominant matrix based on C. The values are, if it is greater than C star, I assign a value of 1, it is less than C star, I assign a value of 0. So, the final dominance discordant dominant concordance matrix is dash, obviously it will remain dash for the 1,1 cell, 2,2 cell, 3,3 cell. So, the values in the other two cells when I am reading along the rows would be 0 1, 1 1 and 1 0. Now, what is interesting is here, if you compare these or if you compare this or if you compare this. So, now this is a concordance set liking. So, if I compare the first, so along the rows are the alternatives which I have. So, there are 3 alternatives. So, this is alternative A1, A2, A3 and along the top which is not written again the alternatives A1, A2, A3. So, when I am comparing A1 to with A2, if I take A1, I am positive, but my liking is not to that level where I am very happy. I am happy, but not to that extent, because it has not crossed that threshold value. Threshold value will depend on the decision maker. But when I am comparing A2 to A1, that means I am taking the reverse decision going to the other side of the fence, then my overall satisfaction for taking A2 is definitely positive, hence I give and is above the threshold value and hence I give a value of 1. That means, given the concordance concept without going to the discordance concept, I would always prefer 2 with respect to 1 based on all the criteria which I have. When I go to the yellow hashed line, the orange one, so let me highlight this. So, first I had already discussed this, now I will discuss the orange one or dark yellow one. So, taking A1 with respect to A3 or A3 with respect to A1, I am always happy. In both the cases, I am always happy. Hence, I have a score of 1 1. When I go to the case of comparing A2 A3, if I take A2 or the alternatives with respect to A3, I am happy with A2. If I take A3 with respect to A2, I am happy, but not to that extent. Well, it has come, I am happy, it does not give me any much extra value. So, this would give you on the level of concordance dominance matrix what are the values. Now, similarly, we should have for the discordant values also. Similarly, we find out the discordance threshold value D star, same formula, summation of all the D K L values based on the fact that you are summing up for all the criteria, and again the division value is m into m minus 1, exactly as I had mentioned few minutes back. D star value comes out to be 0.75. Now, I basically have the discordance dominance matrix. The concordance dominance matrix was F, discordance dominance matrix again I formulate based on the threshold. Now, you see the values, I will just highlight them with the color. So, when I compare A1 to A2 and A2 to A1, A1 values of discordance disliking, I am very sad for taking the A1 decision. But if I take the other side, I go to A2, I am sad not to that level as I was by taking A1. When I go to compare, say for example, A1, A3 and A1, A3 and A1, my level of unhappiness, discordance or disliking is much higher if I take A1 and not A3. But if I take A3 and not A1, I am unhappy, but my level of unhappiness is not to that degree. When I go to A2, A3, my level on unhappiness is 0, that means okay, I have taken that, I cannot do anything when I compare A2 to A3. But when I compare A3 to A2, I am definitely very unhappy because I have discordant dominance matrix value as in that cell is 1. So, I have formulated F, which is the concordance dominance matrix based on the threshold values being crossed, and similarly I have the discordance dominance matrix G based on the threshold value D star being crossed. In that case it was C star, now it is D star. Now, when I compare, so when I am comparing, I am basically multiplying the values of corresponding cell values of F and G. Once I have F and G multiplying means I am trying to find out where I gain in both the sense. In the fact that the level of satisfaction is also positive, cross that threshold value, less of dissatisfaction has also crossed that level value. So, that means if I am taking, say for example, A k with respect to A l, it should be positive that I have taken A k, hence I am happy, and if I take A l not A k, I am unhappy. That means, in both the cases I am both positively positive and positively negative. Negative means in the negative sense, negatively negative, let me use that word, negatively negative, not the minus minus making it plus, negatively negative for taking the decision. So, hence, and because in this case they have crossed that thresholds, hence I am 1 1 multiplying 1 1 gives me a score of 1. That means, I am taking the right decision. But in some case it may be that I am positive by taking the positive decision, but I am indecisive that I have taken the negative decision is not that negative, so hence is 0. So, when I multiply 1 by 0 it is 0, that means I am not doing the right justice to that. Similarly, I reverse that, I have not taken the decision, I am positively 0 and negatively 1, then trying to multiply 0 and 1 also gives me a value of 0. That means, I am taking that decision is not accruing much value to me, and obviously, if it is 0 0 in both the case, multiplication is 0. So, utilizing the dominance concordance dominance matrix F and discordance dominance matrix G, when I find that value, the final cell is E, which is the aggregate score. So, the aggregate score basically comes out to be only 1 when I compare A1 and A3. That means, if I am comparing A1 and A3, in all the sense I am making the best judgment, in other case I am indecisive because there are conflicting criteria which gives me positive and negative benefits. Now, for the aggregate dominance matrix we can derive a partial preference concept. So, if that value of cell is 1, then A k would always be preferred to A l. So, we will eliminate any columns which have an eliminate any columns which have an element equal to 1. So, those would not be considered because they are already positive. So, in case E13 is 1, hence alternative 1 is preferred to alternative 3, which I had mentioned. So, in this case A1 is preferred with respect to A3 in all sense, in the sense I will use the terms in the sense that positive was positive, positive was good, hence I took, in the sense I will write, I am using the green color. So, negative was also negative, so hence good. That means, it is not minus minus is plus. So, I have taken the wrong decision and it is really good in the negative sense. I have taken the positive decision, it is really good in the positive sense. Now, we will go into the concept of the epsilon electron method. So, there is a slight change, and here I will talk about the story which I have already discussed, but I will still discuss in a brief detail. So, if you remember in the asymmetric loss function, when we are doing the utility function, we said that, and I gave 3 examples, I repeat that to freshen up the concept which I will be again doing. So, if you remember, I have the asymmetric loss function giving me 2 weights or the concept. One was the asymmetric loss function and one of the linear loss function when I combine them. So, it is e to the power a lambda minus a lambda minus 1. Lambda is basically the difference between the predicted value and the actual value. Now, if A is positive, the graphs I have already drawn. So, if required I will draw it, but I will build up the story. So, if A is positive and the difference between the estimated value and the actual parameter value is also positive, in that sense you will find out that overestimation will dominate underestimation. When I go into the second quadrant, obviously in that case for the values of A positive, for negative values of the estimated value and the parameter value, you will find the linear part will dominate the exponential part. So, hence in the positive coordinate exponential part is more positive, and in the second quadrant linear part is more positive, but means dominating, sorry I should not use the word of positive. Now, when you take A as negative, in that case in the positive quadrant, first quadrant, as the difference between the estimated value and the parameter value is positive, but in that case the linear part in the first quadrant will dominate the exponential part. When I go for A negative in the second quadrant, for the values of estimated value minus the parameter value is negative, in that case the exponential part will dominate the linear part. So, the examples for the first case when A was positive, if you remember that overestimation would dominate, underestimation was the case when and in case in the dominate in the sense loss function ways would be the case when you are trying to basically formulate the problem for the electrical circuit, where trying to basically stop the machine after the warranty time would be catastrophic. So, if 6 months was there, rather than stopping it at the 5th month, if you have stopped it at the 7th month, then the loss of life accident would be much more catastrophic if you had stopped it at the end of 5th month. So, hence it is better to underestimate. In other case for building the dam, when you basically have any less than 120 meters if you or 120 feet, if you remember I had given this example 120 feet being the actual height. In one case you build it to 122 and another case you build it to 118. In the case of 118, initially you use less manpower, less material, obviously the cost is less, but when the flood comes, the propensity of the flood to breach the dam is much higher. So, hence there would be catastrophic environmental loss, manpower loss, cattle would be lost, everything would be inundated. So, in that but in the case when if it is built to 122 feet, the overall cost initially would be high, but the propensity of the flood to breach the dam would be almost negligible. So, in that case losses would definitely not there. So, in this case underestimation would be more penalized than overestimation. And in the third and in overestimation is more penalized for the electrical one, underestimation more penalized for the civil engineering example, and in other case for the marketing one, when you are trying to float a product with a warranty life, whether if you basically make a warranty more or less than your competitors, obviously your loss will be calculated accordingly depending on the case, that how overestimation or how underestimation have been penalized. So, it will definitely depend on the value of A is positive or negative depending on the problem which you have. So, we are trying to utilize the same concept here. In epsilon electro method, we consider the concordance and discordance sets are not mutually exclusive. So, if you remember in the concordance and discordance sets that values of 1, 2, 3 which were coming out, which is basically the alternatives, you are either clubbing them in the C set or in the D set. There were no case where any one of the alternatives you were indecisive that whether you are going to club it in the C set or in the D set. We are going to consider that now. So, hence we are considering that they may not be mutually exhaustive, that means addition should technically be the null set. So, in this case if you have C is the concordance factor, D is the discordance factor, if that is not equal to the total J set. So, obviously now you will have 3 different sets, which are what? The positive one I will mark it as blue. So, this is concordance is C, which is positive, I am marking with blue. Discordance is red because I do not like it, hence it is red, and the other factor which I am indecisive, I am using the yellow color. So, now you will basically have 3 sets C, D and I, such that the total union of D, C and I would basically be the total universal set which you have for all the sets of decisions. So, again you have the luxury in a sense that you are able to classify them into 3 different sets. Again, the sum of all the elements in C, D and I would basically be the universal set, and none of the element would be there which basically can be in C or D, or can be in C and I, or can be in D and I. So, hence the intersection of C with D, C with I and D with I would always be a null set. So, I am going to consider each and every decisions accordingly and consider that for all the sets of criteria one at a time. Then again that means A1 will be compared with the A1 with respect to all the decisions or the criterias. Then A1 will be compared to A2 based on all the criterias. Then I will compare A3, A4, A5, A6 till AM with respect to A1 for all the criterias. Then I will consider A2. I will compare A1 with A2, A2 to A2, A3 to A2 till AM to A2 based on all the criterias. Then I go to the third row where I take A3 and compare all the alternatives with A3 with respect to all the criteria. Then I do it for the fourth row, fifth row, sixth row till the mth row, where I take each and every alternative in that particular row and compare all the alternatives accordingly. Consider this, I will change the problems accordingly with bring some twist in order to make you understand. So, consider the overall not W is not the weightage, overall matrix which you have based on this wealth, W is the wealth. So, if it was small w bold, it will be the weights. So, these values of the weights or the wealth which you have, or the values you are accruing for any particular decisions are given. If I read along the rows are 100, 200, 200, second being 200, 50, 250, third being 150, 150, 500. These are those values only without any units, where the cells signify the total amount of money one would invest in the jth criteria based on whatever decisions which you have. From this matrix we need to find the utility that actually accrues by undertaking that decisions. So, now we will basically consider some sort of utility function in order to bring that conclusion that utility factors do matter. Now, if you remember that in the first example you have considered the utility function as quadratic. Now, I will just change the utility function as logarithmic. So, consider the logarithmic utility function where we have, I am for a simplicity's sake I am not going to consider the logarithmic with base e, I will basically consider base 10. So, x being the non-normalized values, it will be log of 100, log of 200, log of 200, I am reading the first row. Then similarly log or the values of 200, 50 to 50, 150, 150 to 500 will give me all the cell values for the second row and the third row. So, when I normalize, I am using the concept of sum of the values being undertaken either for the column or the row, and then trying to normalize either through the column or the row, remaining the sum should be 1. If I have that, the values which I have for the x normalized values are 0.31, 0.37, 0.33, similarly 0.36, 0.28, 0.34, 0.34, 0.35, 0.33. So, just pause, do the calculations, you will understand that I am using the logarithmic utility function in order to convert the values in the logarithmic scale, scale means utility function, and then normalizing in order to proceed for the next step. So, with this I will end the 20th lecture and continue more discussion about this epsilon electra and try to highlight how the epsilon electra would be a little bit different than the simple electra one method which you have considered. So, have a nice day and thank you very much for your attention.